Hello, let's talk about the polar coordinate system. And for many of you, this may be something brand new. And so what you see to the left looks like, a target or a bullseye. What we want to do is plot something called polar coordinates, okay? And this is a point. So you have a point in the polar coordinate system that's an R value and a theta value, and you want to place that point somewhere on this polar grid, okay? Now, let me explain it. This middle value right here, that's called the pole, and that would be 0, 0. Just like on an XY axis, the center, when X is 0 and Y is 0, 0, 0. This is called the pole, and it's also 0, 0. Now, what's going on are these circles. They are your radius, okay? So this circle could be a radius 1, radius 2, radius 3, if you count it 3 out, a radius 4, and a radius 5. But now, just like in an XY axis, notice these are not labeled, so they could be whatever you need them to be. If, for instance, you need this to be 5, a radius 10, 15, 20, 25, you can certainly do that, just depending on what type of polar equation you need to graph. Okay, so that's what R is. That's just the radius, and you'll just count out. Theta, on the other hand, what you're used to, is an angle. Okay, so think about your unit circle. All right, so this angle, if I drew this out right here, this angle, that might be pi over 6. The one in the middle might be pi over 4, pi over 3. Of course, this guy straight up and down is pi over 2. If you go around, you can continue to label. This would be pi, right? This would be 3 pi over 2. And right here is either 0 or 2 pi, whichever way you want to look at it. Typically, we look at that as 0. So if you were to plot a point, okay, and let me just make one up. How about 3 pi over 3? Okay, so let's plot the polar coordinate 3 pi over 3. Now, what I tend to do is I tend to do the angle first, okay? I know when you plot in an XY axis, we look at the X value first and the Y value, just because we're reading left to right. But to me, it's easier to find the angle first, so we know where pi over 3 is. And actually, it goes this way, and it does continue backwards. We'll explain why you would go backwards, because I know you're thinking, hey, that's 4 pi over 3 down there, and it is, okay? We'll talk about that in a minute. But if I go to pi over 3, okay, and then I count out 3. So 1, 2, 3. So this point right here would be the polar point graph of 3 pi over 3. All right, so let's practice this a little bit more. I want to plot points in the polar coordinate system. Now notice my polar coordinate system. This time I have angles drawn out for you. It depends on your polar grid. You will always see these circles radiating outward, okay? What may differ is what angles are represented. This one is pretty detailed. Notice it goes pi over 12, which we don't even have that memorized on our unit circle. Then, of course, pi over 6, pi over 4, pi over 3, 5 pi over 12, and pi over 2. So these are broken up every pi over 12. This could also be in degrees. There's no reason it has to be in radians, although we're going to work with radians, but it could be in degrees as well. All right. Now, let's plot these points. So I want to plot the point 3 pi over 4. And like I mentioned previously, to me, this is just me, it's easier to do the angle part first and then count out that many rings if that's what your scale is. So I'm going to find pi over 4 first. Here's, of course, is pi over 4. Now the pole is right here in the middle. That's 0. So this will be 1, 2, 3. So this point right here is the point A, or I could go ahead and label it as 3 pi over 4. Okay, let's try that again with B. You take a minute, pause the video if you need to, take a minute and figure out where 2 negative pi over 4 will be. Okay, so remember the angle first. Now, if I'm going negative pi over 4, and then you tell me, well, that's not labeled. That's okay, right? We know what a negative angle means. Instead of going counterclockwise around the circle, we're going to go clockwise around the circle. So negative pi over 4 lives at the same location as 7 pi over 4. You start in the center, and I'm counting out to a radius of 2, so 1, 2. So this point right here is the point B, or 2 negative pi over 4. All right. Now the next point, we have negative 4 pi over 4. Now this we haven't had a negative radius yet. Let's think about this. Okay, so pi over 4 is right here. And if we were doing a positive 4, it would be 1, 2, 3, 4. It would be right the next one out from our A value. But negative 4 means you count backwards the other direction. So it's like a 5 pi over 4 angle. So we're counting backwards. So you catch that? Again, the negative means go backwards. Not in the angle, but as you're counting. So again, positive 4 pi over 4 would be right here. So negative 4 pi over 4 will be like you're counting out the 5 pi over 4 angle. So 1, 2, 3, and this is negative 4 pi over 4. Okay, so make sure you get that. You count in the backwards direction. Now look at this guy. This is both negative. Now this, means you go, again, clockwise. So you're going backwards around the circle. This means you go backwards when you're counting your radius. All right, so let's do that. So I've got negative pi over 4. So first let's find the angle negative pi over 4. It's along here. It lives where 7 pi over 4 was. Now if that said positive 5, negative pi over 4, I would count 1, 2, 3, 4, 5. I would be right here. Okay, I'm going to put a little open circle right there. That's not it. Okay, this would be, if I labeled it, that would be positive 5, negative pi over 4. Okay, but if I want to go negative 5, negative pi over 4, first again I find negative pi over 4, this angle here, but if I count negative, then I'm going backwards, 1, 2, 3, 4, 5. So this guy right here is our point D, which is again negative 5, negative pi over 4. There is something I want you to notice about these points, and you may have already figured this out. There is more than one way to name a point. Right? So this green guy down here, C, I could have also named this, see, we're out 1, 2, 3, 4, and at the angle 5 pi over 4. So C could also be called 4, 5 pi over 4. See how that works? So this naming is not unique. Matter of fact, you could do something else with it too. How about we go backwards around the circle? So that would be, if we start here and we go backwards, it'd be a negative angle, right? How far are you going? You're going an angle of negative 3 pi over 4. So we could call that negative 3 pi over 4. I put it in the wrong spot. Angle's always second. Didn't leave myself room there. Let's try that again. So how about negative 3 pi over 4? And then if it's here, then we're counting directly out. So that would be positive 4, negative 3 pi over 4. Okay, another way we can name it, just like we did negative 4 pi over 4, we could say that this is negative 4, keep counting backwards, but pi over 4 could also be 9 pi over 4. You could go all the way around the circle and back again. Now the point of this is to let you know these points are not unique. The naming of them is not unique. The point is unique. It is only this point and no other point. But the way you name it, or what you call it, or how you get there, is not unique, and that's not like an XY axis. An XY axis, if you say the point square root of 2, 5, there's no other way to say the point square root of 2, 5. But for polar coordinates it is, and so the next problems I want to take a look at is how can we name these several different ways. Alright, so check out this first point I have, 3, 315 degrees. And I promised you earlier that it would be mostly in radians, but we do have some degrees problems. I don't want to just ignore degrees and make them out like they're bad guys. They exist too. So where in the world is 315 degrees? Like I didn't give you degrees on here. Not a problem, right? We know this guy over here, of course, is 180 degrees. This is 270 degrees. You know what? Each of these are 15 degrees apart. If you think about it, that's 15 plus 15 is 30 plus 15 is 45. We do know pi over 4 is 45 degrees, right? Plus 15 more would be 60 degrees, plus 15 more is 75 degrees, plus 15 more is 90. So you get the point. So how do I get to 315 degrees? Well, we know all the way around is 360 degrees, and I could count backwards to get to 315, or I could count up to get to 315. So remember, this is 270, right? I add 15 to that, that'd be 285. Add 15 to that, that would be 300. Add 15 to that, would this guy not be 315 degrees? Another way to check it is pi is 180, right? So I do 7 times 180 divided by 4. And that's definitely 315 degrees. So let's plot this point. So I found 315 degrees, okay? And my radius is a positive 3, which means I count directly out in this direction. So again, 0 is in the middle. That's 1, 2, 3. So here I am. That is the point, 315 degrees. Okay, and it says find 2 other representations of the same point. Now, some people always get a little smart alecky about here, and they want to change that to radians. Like they would say, that's 3/7 pi over 4. Well, yeah, it is. But if you're working in degrees, keep it in degrees unless you're requested to go the other way with it. So when we rename this, let's keep it all in degrees. Okay, so one way I could do this is if I go backwards around the circle, right? So instead of going all the way around to 315 degrees, I could go backwards, and that would be, 15, and 15 is 30, plus 15 more is 45, or y'all know that's 45 degrees right there. So I could say also 3 negative 45 degrees, okay? So that's with a positive radius and a negative angle, all right? Now, let's try this again. How could I do it this time with a negative radius and a positive angle? Okay, well, let's look backwards here. So 315 degrees, if I go backwards, is this guy right here. I'm trying to do a dashed line. There we go, which is 3 pi over 4. But y'all, what's 3 pi over 4 in degrees? Now, again, you could start counting on your circle. You could say 3 times 180 and then divide that by 4. I think I'm going to go right here. That's 90 degrees. Plus 45 degrees is going to give me 135 degrees, right? Okay, so now let's think about this. If I go 135 degrees, okay, only go to here, but then I count backwards, that would give me my angle, right? So that would be a negative 3 and then 135 degrees. Okay, so this time I've got both positive up here. That was the original. Then I tried it with a positive radius and a negative angle. Then I tried it with a negative radius and a positive angle. Can we come up with a smooth way, keep all these warm colors, a smooth way where they could both be negative? How about that for working your brain? Okay, so a negative radius and a negative angle. Okay, well, negative radius, we already know we need to be along this line, or angle needs to be along this line so we could count backwards to get to our red point. We're always trying to get to this red point. A negative radius means we would go this way around. Okay, so what is, a negative angle, I said that backwards, I'm sorry. A negative angle means we would go backwards or clockwise around the circle. Now what would that angle be? You know this answer, right? It'd be negative 315 degrees, right? So negative 315. We'd already gone all the way around to here. Well, that's just doing the opposite. No, it's not. Really, if I was smart, I would erase that. But I'm not. We all make mistakes, right? Okay, so let's try this again. Negative all the way around. And that's negative 180, right? And then I've got another 45 to add to that. So that is not negative 315 degrees. That is negative 180 plus 45, which is negative 225. Check me twice, please. Send me an email if I'm wrong. Negative 225 degrees. All right. And we'd already established that this was, you know, if you count out positive 3, negative 225, you would be 1, 2, 3 right here. Okay, that's not what we're doing. We're counting negative 3, which takes me 1, 2, 3, of course, right here on my red. So I have named that thing 3 different ways. 4 different ways. We had the original, and then we did 3 attempts. Now notice it said find 2 other representations, you know, how to go above and beyond and give you 3. But I wanted you to see a version. So here's what I want you to do. Take a minute and do that same thing with B down here. How about try to find 3 representations? How about do both of them positive? And then we've already got the one where the radius is negative and the, well, 0 is no fair. Let's talk about that one together, because 0, you know, you're not going to get all those different options. So what I'm going to do is I'm going to get rid of all of our scratch work for the first problem. And you be thinking about where you're going to plot that point to start with. Okay. Are you wondering if that 0 is in degrees or is it in radians? And then you got to ask yourself, does it matter? 0 is 0, right? Doesn't matter. Okay, but now I would need to give you some firm directions about whether I wanted this in degrees or whether I wanted it in radians, because 0 you can't tell. Okay. All right, so let's do this. And let's assume this is in radians. We've already looked at a degrees problem. Now let's look at some radians stuff. Okay. So first let's plot this point, negative 3, 0. All right. So positive 3, 0, of course here's 0. So positive 3, 0 would be 1, 2, 3 would be right here. That's not it. Okay, so negative 3, 0, I count backwards. 1, 2, 3. So this guy right here is negative 3, 0. So now clearly you see right off the bat another way we could name this thing. All right, so how about let's do this. Let's do positive 3 pi. You agree? Because we're at the angle pi, and we're counted out 1, 2, 3. That is definitely positive 3 pi. And we can name this the same 3 different ways that I talked about before. This is all positive right here. This is with a negative radius. All right, now let's see if we can do this where we have a negative angle. Can you think of a way to do this with a negative angle and a positive radius? So it means I keep it positive 3. Negative angle means we would go this way. Well, that'd be negative pi, right? All right, so that would be positive 3, negative pi. Okay. Now can we think of a way where they're both negative? You have to be a little more creative. So if they're both negative, that means I need this angle over here to get the negative 3, just like we started with 0. But if I want a positive angle, how about I say negative 3, 2 pi? That would give us a positive angle, right? And that's where it got a little weird, because 0 and 2 pi are the same thing. But you can go all the way around and back again. And then if you count out positive 3, 2 pi, that would be here. But negative 3, 2 pi, of course, would take us right there where we need to be. So practice this. Make sure you're comfortable with renaming these points, because the naming of these points is not unique at all. Hey, so I jumped ahead on you and I decided to come back to the screen. You know why? Because the next 2 problems ask you exactly the same thing, but in radians. So maybe this shouldn't have been radians. It's in degrees. That's an easy fix, right? This would be 3, 180 degrees. The second guy would be 3, negative 180 degrees. And this third guy down here, which I meant to make a different color, would be negative 3 and 360 degrees. But I was trying to make them both negative. So negative 3, negative 360. That'd work too, right? All right, here we go again. Okay, so let's plot these. We're getting plenty of plotting practice, but you got to be able to plot a graph, right? So that's the idea. You practice a whole lot of plotting points in the XY axis before you really learned how to graph lines. All right, so plot the polar coordinates, find 2 other representations of the same point. Now, these are clearly both in radians. Okay, so our answers need to be in radians. So I want to plot the point to negative 7 pi over 6. Now again, hint, do the angle first. I know where positive 7 pi over 6 is. It's right here, right? So that's all the way from here to here. So if I go negative 7 pi over 6, it's the same idea. We go all the way from here to here. You agree? That would be negative 7 pi over 6. Okay, everybody comfortable with that? And then you count out 2 in that direction. So 1, 2. We're right here. So again, that is the point to negative 7 pi over 6. All right, now we're supposed to rename that. So let's go with the most obvious, the positive choice. All right, so if I count just straight away 5 pi over 6 for my angle and a radius of 2. We just counted out 2. So that's the most obvious. That's the easiest way to name them to me. Okay. Now let's try this with a negative 2. So what is this going to look like if I make this a negative 2? Which means if you think about it, you're counting out this angle right here. You're looking at that angle right there because you've got to count backwards. So you could say negative 2, 11 pi over 6. That would do it, right? Because you would go all the way to 11 pi over 6, which is here, and then you count backwards, negative 2, 1, 2. All right, good. Got it, got it. One more. All right. How about let's make them both negative. So a negative and a negative. Now again, I said find 2 other, but again, above and beyond. All right. So if I want to make them both negative, then we already know the 2 is going to be negative. So that's a negative 2. But how can I do the angle negative? So again, we need to be along this angle to count backwards to get to negative 2. So I need to know that angle right there, negative-wise. Y'all know what that guy is. That's negative pi over 6. All right? Comfortable with this? Again, labeling points is not unique. The easiest thing to do is make them both positive. All right? So you don't have to work your brain so hard. But you'll run into these negative values even when we're doing some solving in a little bit. You'll see what I'm talking about. You got to know which is the correct version. All right, so let's try this again. I'm going to get rid of my scratch work on top of my polar coordinate grid and change to purple so we're all matchy. All right, so negative negative 1 pi over 2. Let me read this correctly. Pi over 2. So first, find pi over 2. Here he is, right here. So it's this line. But it says negative 1, so I'm not counting to here. That's positive 1 pi over 2. I'm counting to right here. So there's our guy right there. Make sure that's right before you start doing any more work. And I feel comfortable with it. That is definitely pi over 2, negative 1 radius. All right, so now let's start renaming this guy. Again, the most obvious is when it's all positive. So this is the angle 3 pi over 2, and we counted out 1. So 3 pi over 2, positive 1. So that's a version. Let's find another version of this. Okay, so how about let's try, oh my goodness, my brain is not working well today. Look, backwards, just backwards, just wrong. All right, so how about positive 1, 3 pi over 2, written in the correct form. You don't switch your x and y's up, right? So you don't switch your r and theta's up, even though that's what my brain wants to do today. All right, so now let's try a negative angle. Okay, so if I keep the positive 1 the way it is, how can I write this angle with a negative angle? And I know you all know that's negative pi over 2, right? Okay, and then again, to go above and beyond, let's work on making them both negative. So how could I do a negative 1, and what angle would that be if I did a negative 1? Okay, now a negative 1 means I need to not be on this line, but I need to be on this line right here, which is pi over 2. I agree with you there. Okay, but we're trying to go backwards to get there. So what is that? That is negative 3 pi over 2. So again, 3 ways to name negative 1 pi over 2.